All right. You let me know if it looks like your team is all on.
Okay,
I
so
think everyone's here. Yeah.
That look like anyone who shouldn't be on. All right. Yeah, sorry about that.
So, yeah.
The Zoom meeting time for some reason was shifted by 15 minutes. We weren't able to log on time. But we're making it work, making sure everyone has plenty of time to have for their Q&A. I was able to watch your presentation. And I do have some questions. First of all, awesome video. Really great job. Obviously put a lot of work into that. I'm super stoked because you guys have a hybrid motor, which I always love getting to see hybrid motors. We don't get to see very many of them. So there's a lot to talk about there. First of all, is this your first year doing a hybrid? How many times have you done hybrid before? What's the background on the development to the hybrid?
yeah, this is our first hybrid motor, but it has been under development for 3 years, I think now. So it's a pretty long project, and we have some ideas to upgrade it and make it a second version of this motor, just enhancing it. But still, that's just the first project.
Okay, great. And forgive me if I don't remember everything about the video. Were you able to do hot fire testing on this?
Not yet,
okay.
Unfortunately. We try to do our best to not only make the test, but when we saw that we wouldn't be able to do the test due to the pandemic here in Brazil, it's pretty harsh. We try to make simulations and everything to simulate every aspect of our motor and try to do something almost like in fire test, but we know that it just does. We can't substitute a real life fire test by simulations.
Okay, how far in build have you been able to get, or is it all right now still in paper component testing?
Okay, the motor pieces are built. We have in the poster, I think we have pictures of the pieces. In fact,
so yeah.
Yeah, we have the base, the test base already built. We were working on the communication and instrumentation systems. We didn't have bought all the components, but all the coding is under development.
Okay.
Yeah, just.
And the were you able to do any cold flows? Do you have the oxidizer tank built yet, or is that still in process?
Okay, we have a sponsorship for the oxidizer tank. It's Air Liquide, French company, but we couldn't actually do the code flow test because every present or testing, we needed to not only have access to our lab, but to our testing facility that is in another city. So all this logistics systems couldn't work during the pandemic. That's the main problem here.
Yeah, and you're not the only team that obviously has had this problem. So it's just, I'm just trying to get, what information I can on it. The injector system, how is the injector system, how does it work? How does it controlled?
Yeah, it is not controlled. Since it's the first project, we try to keep it the simplest as possible, just to have a test and be able to develop over the results. So we don't have a actuator. So it's just it's what we call a solid hybrid because we don't control it at all. So we just fire it and it happens. The injector orifice is the same as the feeding orifice. So the feeding procedure takes place in the same plate and the same hole that happens in the injection. Okay, could you understand that?
So how, I guess I'm a little unsure. How do you, because obviously it's a pressurized vessel, right?
Yeah.
You've got your NTO in there. You've got however many pounds of oxidizer in there. How are you keeping that under pressure until ignition?
Yeah. So I'll try to take you through this. while we are feeding the system, the injector hole actuates as a feeding hole. So we are feeding through the same hole that the injector happens. For the ignition, we burn the hose that we are using to the feeding process, and then there is an orifice for the injection.
Okay.
And we also close all the valves, right? So there's no feeding during the burning, which is really important to our security procedures, right? So
I saw you have a vent on top, so you have a place.
Yeah, so there's a vent on top, and then when you're feeding, the vent is going off. And once we stop the feeding procedure, we just close all the valves from the tank outside of the rocket, and then we just prepare for ignition. So when we ignite the main polymeric hose that we have inside the tank, we can start ignition and also cut our connections with the soil, so we don't have any problems with the rocket being just like being grounded, right? So it's just like it's not locked on the ground.
So how does the filling disconnect?
It doesn't disconnect. We have a solid propellant, a KNSB propellant, molded around the feeding hose, and when the ignition starts, we burst the hose with that propellant. So the propellant not only begins the ignition by providing the necessary heat, but it bursts the hose.
Oh, okay. Okay. All right. It's very different. Yeah.
Yeah.
Okay. And then the fuel grain, how did you develop your composition for the fuel grain?
It is actually pretty simple. It's just a paraffin wax, but we mixture it with, I don't know the English term for it, but I think it's a powdered carbon, like just a fine powder of carbon. We call it negro de fumo. Right? Yeah.
Where it's the pigment you utilize in tires, right? So to make it black, so we can absorb some part of the energy, right?
Sure. Okay.
Yeah. The idea is just to make the grain opaque so that there is no radiation happening inside the grain and all the heat is focused on the surface of the grain.
Black,
the inner surface, right?
Okay.
And there's also some fixer, right, to make it a little bit rigid so we don't have problems with the temperature on the desert before operating, right?
Yeah. Do you have some sort of insulation or anything like that between the outer shell and the grain, the fuel grain?
Yeah. We have an EPDM rubber sheet fixed, actually glued inside the chamber.
Okay.
So it's outside the grain.
What process are you using to pour the fuel grain? Are you planning on using to mold the fuel grain?
The fuel grain, it is just a simple mold. We melt the paraffin wax mixed with that carbon thing. Then we mold it in the shape of the grain that we want, and then we may have the EPDM sheet around it glued and fixed around the grain. So it's just one thing, the sheet plus the grain, and then we slide it through the chamber.
And then do you core it then? Do you hollow it out in the center?
No, the mold is already holed. That's the mold, yeah.
So you got an outside cylinder and an inside cylinder for the port, right?
I got it. Okay. And then so we've got, is that one of your team members?
I guess it's not.
I think so, yeah.
Okay. All right, there we go. The payload. Can you tell me a little bit about the pendulum? I thought that was a really interesting payload. Can you tell me a little bit about that?
Well, our payload was developed along almost a year. It consists of a scientific experiment. It's about an ABS pendulum fixed at DC motor inside, controlled by a 10C 3.6 microcontroller. And the main objective of the experiment is to maintain the pendulum at a vertical position during the flight, and also collect the data about this experiment. We had a lot of modeling, a lot of simulations to be able to develop and tune the PID controller to implement it correctly. So to summarize, it's basically an experiment to maintain the pendulum aligned with the symmetry axis of the rocket along the flight.
And it's if I understood this correctly, it's a it's like a standing pendulum versus a hanging pendulum.
A simple panel fixed at the rotor of a DC molder. It's
Yes, but
fixed at a molder,
Andy,
and
I
the
think
molder
she-
control.
Is it hanging this way? Like if the rocket's launching, is it hanging this way, or is it? It looks like
No,
it was.
it points upwards. And
Yeah.
So it points in the direction of the rocket.
How does
going
that
up.
work with the acceleration of launch? Wouldn't that sort of pin it down?
That's why we have the control system to avoid that. We ran some simulations and we are confident that it would work on a real launch. We
Okay.
presented it on the payload challenge today.
Oh, cool.
earlier.
I wasn't able to go to that. I apologize. Maybe I'll go back and look at that. It looks like a really interesting payload. I liked it. I'll have to watch that. Okay. Let's see. All right. You chose a von Karman nose cone. Is that something you've used prior years, or was that a trade study for this year?
No, it was under development in 2019. We are trying to build entirely in carbon fiber. So we have a 3D printed mold, and we do a mold using the model 3D printed, and with the mold, we build the nose cone actually. So it's a large process, but we are able to achieve a entirely carbon fiber. So there's no steel and there's no inside plastic or something like that. It's purely carbon fiber. We had made the first prototype, and it seems that it's gonna work, but we needed more tests because we couldn't finish the project since the pandemic, but it was under development and had some good results.
Okay. And what about your fins? Are those also carbon fiber?
Yeah, that's also a development. It has a carbon fiber core. It's a plate, and we cover it with resin, epoxy resin, the same as the carbon fiber. So it has a rigid core and a airfoil shape made entirely by resin.
Okay. And how are those affixed to the body?
They are attached by the inside, just resin, applying a layer of carbon fiber also by inside, and we have planned also an external layer if necessary, so we can ensure stiffness.
Okay. So there's no like mounting core or something. It's just carbon fiber and carbon fiber with a resin for gluing it down.
The same core plate goes inside the tube, and by inside we there's a like a level. I forgot the word, but you can glue it by inside since it's inside the tube.
Yeah.
The core goes through the tube, so we can glue by the inside.
Yeah. Okay. I think we're just about out of time. Is there anything else that you would want me to know about your project before we finish up?
I think the parachute is also very interesting since
Yeah.
a new system, and Isa can talk more.
Okay, you got 1 minute.
Okay. This year we're using a riffing system, so we have only one parachute, one ejection system, and the riffing cutter is divided in two parts. We have the electronics inside the nosecone and a combustion chamber, like soon. I don't know if that's the word, but it's fixed to the parachute riser and it's connected to the electronics. So when there is a altitude of 400 feet, there's a disriffing, and the riffing line is burned, so the parachute is in its maximum
Awesome.
like diameter.
Right. Full deployment. Got it. Okay, great. Thank you so much. Muito obrigado. Thank you so much. I really appreciate all your hard work this year, and good luck with everything. Go check out some fun sessions today.
Thank you very much.
Thank you very much.
Thank you.
Hello, everyone that just came.